Let's see when all are present. Prashant joined. Write your name so that I'll be able to know when all are there. Gautam, good evening, beta. Good evening, Gautam. Prashant and team. Good evening. Get ready, everyone, for the new session, new learning for relation and function. So, what is exactly relation and function? The most important thing is, if somebody will be telling you what is relation, then you will be saying that you are related to your father, you are related to your mother, you will be saying that you are related to your friend. So, there is always a connectivity. Rohit, good evening, beta. Good evening, Rohit. Class 12 syllabus we are starting, and here we are understanding what is exactly relation and function. So, relation first we are going to understand, and in the beginning part of the section, we have to understand that from where relation is coming. Okay, now first part is, if somebody will be telling you that in your house, how you are related to your family members. In your house, how you are related to your family members. Then you will be saying that, yes, I am having a mother and she is my mother, so I am her son or I am her daughter. Okay, so like that you are going to say. Father, mother, brother, sister, that is exactly a relation. Fine. Now in mathematics also relation is there. I want all the children, Kabilan, good evening. Good evening. I want all the children to just write the name, and from the beginning for class 12 session, I want all to just start backing up. Now, whatever you have done in the past classes, it is different. Now, from here onwards, we are going to understand class 12 syllabus in a very precise and a very important way. Fine. So, ready everyone? Ready everyone? Now, what is called as relation? Now, relation, no answer for relation, because you will be saying, auntie, right now itself says na ki family people are there and all are related to each other. That is relation. Exactly, this is not relation in mathematics. Now, we have to first generate Cartesian product. Cartesian product. Cartesian product. And we are going to form relation from this only. Fine. So, first important point is to take out the Cartesian products of two sets. Okay. How many sets? Two sets. I repeat, Cartesian product of two sets. Prashant, are you there? If you are there, please kindly say good evening to me. Okay, Prashant and team, if anyone is there, kindly say good evening to me, because I am waiting for all of you. Fine. Now look here. So Cartesian product, when we are talking about Cartesian product, just 1 minute, I have to give one message. After giving that message, I'll start. Good evening, Arjun. Arjun, just inform to Prashant and say everyone to join beta. Okay. Nitish, good evening, beta. Good evening, Nitish. So first we are going to understand Cartesian product. For Cartesian product, we need two or more than two sets. You have to just understand content by content this point. For Cartesian product, what you need? You need two or more than two sets. So right now I am first forming one set. Okay. So if A and B is written here and B is there and it is written as 1, 2 and 3, then how to form a Cartesian product of A and B? How to write it as? Okay, Arjun. Now look here. So first work is A cross B. When you are writing A cross B, it will become what? How to write it as A cross B? So when you don't understand anything, when A cross B is writing, A set element first A and B. So give A as priority and B element is coming as 1, 2, 3. So it will come like this and like this. So first we will write A comma 1 and then it will come A comma 2 and A comma 3. And then it will come B comma 1 and then it will come B comma 2 and it will come B comma 3. So like this it is exactly coming. So what I have done here is Gautam, Arjun, okay, A cross B, fine. A cross B here when you are writing, you have to just understand that 6 elements will be there. So A is exactly having what is the cardinal number of element A. So most specific words I am using. For 12th class you have to use these words. So here I have written a set A. In that set I have taken 2 elements. So how we are going to write that? We are going to write cardinal number of A equal to 2. How we are going to write? Cardinal number of A equal to 2. Absolutely correct, Arjun. And here cardinal number of B equal to 3. And you know what? Cardinal number of A into cardinal number of B will be equal to cardinal number of A cross B. Cardinal number of A cross B. This is a very important formula which specifies the cardinal number. That means how many elements will be there in a set. Their multiple we are finding. Absolutely correct. Arjun, Gautam, absolutely correct, and this is exactly the way of writing. Fine, I hope you might have understood. Come on, Rohit, Kabilan, tell me fast. Yes, this is the formula, Arjun. So exactly NA cross cardinal number of A into cardinal number of B equal to cardinal number of A cross B. Cardinal number of A cross B. Now, I just want to ask one question. Is this possible? Is this possible? Cardinal number of A cross B will be equal to cardinal number of B cross A. Is this possible? Is this possible? Cardinal number of A cross B is equal to cardinal number of B cross A. Cardinal number of A cross B is equal to. Is it possible, Arjun? How it is possible, Arjun? Number only we are making. Number only we can make equal. But if somebody will be writing this one, so cardinal number means number of Cartesian product present in A cross B and number of Cartesian product present in B cross A. So here specifically we can say that yes it is, but A is not equal to B, Arjun. Here never do that mistake because both are different sets. Both are different sets, and in class 11th what you have studied that when two sets will be equal, when we can say that two sets will be equal. How and when we can make two sets equal? From the beginning section understand. Look here, A is coming as element AB. B is exactly containing element 1, 2. So they are equivalent set, but they are not equal sets. What is called as equivalent set? When a set is having equivalent set. Equivalent. So I am just explaining because it is the introduction class for Cartesian. So I am just explaining wholesome amount of information to you. So first what we are doing here is A is exactly coming as two elements. A is having. Yes, Arjun, when you will take that example, then it will be coming as equal sets. Then it will be coming as equal sets, Arjun. But here you have to be very careful. My duty is to tell you where you can fall and where you can be exactly going to be very strong. So here, this point you have to pick, Arjun. We cannot do anything. I am just going to teach you this part only. So now look here. So this is called as equivalent. Equivalent means what is the cardinal number of set A? Come on, tell me. Cardinal number of set A means how many elements are present in set A. Then you will be counting it. You will say 1 and 2. So 2 elements are present. Now I am just going to say that what is the cardinal number of set B? Then you will be saying, Auntie, cardinal number of set B is also 2. So when cardinal number means number of elements of set A will be equal to number of elements in set B, then they are only equivalent. They are not equal. Never mistake and tell them that they are exactly equal. They are not equal, they are equivalent. They are not equal, they are only called as equivalent. But when you will be writing like this, what Arjun has given the example, that A is having 1, 2 and B is also having 1, 2, then what is there? First thing, that these two sets are having identical element. Identical element means common element. Like here 1, 2, 1, 2. So they have the same element present there. So we can say that these two sets are exactly equal. Now here you don't have to do anything. You will be saying that no, these two sets are equal because both are exactly containing the same elements and their number is also same. Their number is also same. Understood? This is a very simple thing, Arjun, and you know what? Equivalent and equal. Every time students are making mistake. So my duty was to tell you that this is the point where you can make mistake. So that I just rectified you there only, that this is the point where you can do mistake. Fine. So now will you be able to do mistake here? Now, very good, Gautam. So now I'm just going to go back to my point because I asked a question from you. I asked a very important question from you. Yes, that is exactly equal and equivalent. See, you have to understand that equal sets are always equivalent. Just take my point nicely. Equal sets are always equivalent, but equivalent sets are not equal. This is a very important point to remember. Equal sets are always equivalent, but equivalent sets are not equal. And this is, don't do this mistake. Once you will do this mistake means throughout the life you will be taking that same score and thinking that what massive mistake I have done that day. Okay, so Vikas, okay, good evening Vikash. Good evening. So we just started right now and we are talking about Cartesian product and we are just discussing about how equivalent set is exactly different from equal set. Equivalent set is exactly equal from different from equal sets. So equal sets are always equivalent. Equal sets are always equivalent. Equivalent set cannot always be equal set. And we have seen that example. A very simple example, we have seen that they both are exactly looking equal, but when we went inside and checked, the elements were different. Okay, so this is exactly called as equivalent, but they are not equal. Understood the concept? So now next important point is equal sets always equivalent, but equivalent sets are not always equal sets. Absolute, bang on point. Now understood? Now shall we go for the next part of it? Here, the next part we exactly did one Cartesian product and I am going to go back to the Cartesian product and we are going to just understand that here equal and equivalent concept you have understood. By playing itself we understood the concept of equal and equivalent. Now next important point. Shall we go to the next important point and talk about this case? So is it exactly equal, equivalent or equal? Equivalent or equal? Equivalent or equal? What can you say about this point? Is it equal or equivalent? Think nicely and talk about it. Okay, Prashant, start karo now. Fine, no problem. Arjun, that was nice meeting you, Arjun. Nice performance. Now look here. When we talk about this case, we have to just be very, very specific. Whom you are dealing with, how you are dealing with. So this is exactly A cross B and B cross A. So when you are writing Cartesian product A cross B, see first A element you are writing A1, A2, A3. Then B1, B2, B3. In the same way, when you will be writing, absolute correct Rohit, bang on performance beta. So when you will be writing B cross A, When you will be writing B cross A, how you are going to write? Come on, this is your work now. This is your work now. Tell me how you are going to write B cross A. B is exactly containing element. Whenever you are going to write B cross A, this is a very important formula. I talked about Cartesian. Just remember this one. I used to play with Cartesian like this. It's like very important and very interesting also, huh? So now look here, when B will be written as 1, 2, 3 and A is written as AB, then how we are exactly going to present it? Equivalent, equivalent, absolutely correct. Shall we go back to the next point here? So if I am doing B cross A, can you tell me the elements? Type and send me the elements. What will be the elements present there? B cross A. In B cross A, what will be the elements present there? What will be the elements present there in B cross A? Then you will say that when I am saying B cross A, then give priority to the element of B first. So how we are going to give priority to the element of B first? So we are just going to write as 1A, understood? 2A, 3A. Then 1A, sorry, 2A, 1B, 2B and 3B, story over. This is exactly going to be B cross A. So now this is A cross B and this is B cross A. Okay, can you tell me any element is common? See, they both looks equal. Yes, Gautam, absolutely correct. They both are looking equal, but are they exactly equal? Are they exactly equal? See, the number of elements present inside, let's check this one out, and this is what I was talking about. Now look here, 1, 2, 3, 4, 5, 6, that is cardinal number of A cross B is coming as 6. 1, 2, 3, 4, 5, 6. Cardinal number of B cross A is equal to 6. That means they both are equivalent. Equivalent sets. But are they equal? Are they equal? No. A cross B is never equal to B cross A. Never we are going to make them equal. The reason behind is, for A cross B, you are writing element as A comma 1. For B cross A, the element is written as 1 comma A. And A cannot be equal to 1 and 1 cannot be equal to A. So this story itself finishes here. So we are not going to use this furthermore. We are going to keep it till here only. So A cross B will be coming as B cross A. I hope you might have understood this point. Come on, quickly tell me you have understood. Yes, yes. Equivalent. They may be equivalent, but they will not be equal. They may be equivalent, but they may not be equal. So this was about Cartesian product. Now next important point is, so we understood the property of Cartesian product. Cartesian product, whenever we are taking of two different sets. What did I said? Cartesian product of two different sets, whenever we are taking, then they may be, they are going to be equivalent, but they will never be equal. Okay, they will be equivalent, but they will never be equal. Understood, Prashant? Now we are going to go for the next level questions. Next level question is, now I am just going to talk about Cartesian and relation. Cartesian and relation, because a very important point coming here is, if somebody will tell you that, can you create some relations from Cartesian? Can you create some relations from Cartesian? Then you will be saying that, Kanti, what is the condition where you are talking about relation in Cartesian? See, we know that relation exists. Relation, like I told you, in family you have relations, you have family members relations. But here, what is the meaning of relation in Cartesian? Then you are just going to check what is the meaning of relation in Cartesian. First, you just check this one out. A is exactly having two elements, 1 and 2. B is exactly having 2 element, 2 and 3. Now, just see this one very nicely. So first you are writing A cross B. When you are writing A cross B, so A element will be written first. So what is A element? A element is written as 1, 2. Then B element will be written after that. Then how we are exactly going to do the Cartesian of that? Yes, learning with Prince Vikas. Hey, Prashant aaya nahi aaj kya? So now look here. 1 2 1 3. So it is exactly going to come as 1 2 1 3, and here it will become 2 2 2 3. Now in this condition 1 2 1 3, because 1 2 1 4, ठीक से ले, उसको छोड़ रहा है, 1 2 1 3 1 2 1 3 2 2 2 3 1 2 1 3 2 2 2 3. Gautam, where are you? Rohit, Kabir and everyone, tell me. Nitish, 1 2 1 3, what you are going to write? 1 and 2 1 and 3 2 and 2 2 and 3 1 and 2 1 and 3 2 and 2 2 and 3. Okay, so this is exactly the way of taking the Cartesian product. Now I started from the started part itself. I started talking about family. I was only talking about like relation is just like coming from the family, relation is coming from the family. This is your family, this is exactly your family. Fine. Now from this only you have to find relation. Like in a family, if somebody will be telling that father, mother and 2 children will be there, then if somebody will be asking that who is the father of these two children, then you will be saying the name of the father, mother name, then you will be saying the name of the mother. Who is the what is the name of the child, you will be saying the name of the child. Means what? From the family from the family itself you are taking out the relations now. From the family itself you are taking out the relation. It's not like you are taking out a stranger, talking about a stranger, and you are connecting that stranger with the family. No, that is not a part of the family. So that means you cannot connect a stranger. But if that stranger lives in the family, come and lives in the family and gel out with the family members, that means now it is a part of the family member. Fine. So in the same way, when we talk about Cartesian, look here, there is 2 different families. So A is a stranger to B. They both are stranger to each other. But what happens here is कि when they are forming Cartesian product, the output is exactly the resultant of a new family. So now a new family is made. A is a set stranger family, B is a set stranger family. When they made a Cartesian product, they made a new family. Fine. Now once they made a new family, and if somebody will be coming and telling what is the relation, then how we are going to explain the relation? If relation they are asking that here, don't expect relation to be like father, mother, child and son. Here the relation will be different. Now tell me what is the answer here. One relation is existing between A cross B. So when A cross B is exactly having the family members, like these are the sets, these are the element present in A and B. Now relation is कि any ordered pair. We are generalizing the statement and we are saying that कि x comma y is exactly any ordered pair, and this ordered pair is belonging to this one. And what is exactly the most important point is it is a part of the family. Fine. And you have to identify then when both x and y are prime. When both x and y are prime. Come on, you can do it here. It's very easy. When both x and y are prime, you can do it. When both x and y are prime, think about it. When both x and y are prime. Gautam, don't go for B cross A. Now here relation exists between A cross B. Cartesian of 1. So when we were talking about previous one now, so we were understanding the properties of Cartesian, Gautam, and that time we understood that A cross B will not be B cross A until and unless A will be equal to B. That was one of the concept, Gautam. Now here we are exactly finding only A cross B, and we are exactly framing the elements. After framing the elements, we told that one relation is coming from this A cross B, and this relation is the out of this ordered pair, this is a generalized ordered pair, and this ordered pair is saying that both are prime numbers. Both are prime numbers. Absolute, Vikas, nailed it, super. Now look here. When both are prime numbers means what? Now here select that which one x, y common, means here generalization means what? X and y can be 1, 2 also, x and y can be 1, 3 also, x and y can be 2, 2 also, and x and y can be 2, 3 also. So x and y can be any one. X and Y can be anyone. That's it, Gautam. You nailed it now. Now here you have to exactly understand this point that ki now this is exactly the set of prime number, because they told na ki this ordered pair is there and X is also a prime number and Y is also a prime number. So you told that okay fine, that relation is present inside the family, and that relation is exactly this one, that is 2 comma 2 and 2 comma 3. Understood? See, I didn't did any big work. I just explained you what is exactly Cartesian and how you are going to find the Cartesian part. But you have to now understand one thing, what is exactly relation. You have to understand this point, that what is relation and how relation is existing between A cross B. How relation is exactly existing between A cross B. So we have seen that out of all these sets, out of all these elements, relation is not existing for all. Relation is exactly containing 2. So that means we understood one very important point here, that ki relation is a subset of A cross B. Relation is a subset of A cross B. So if somebody will make us fool by saying that relation is exactly A cross B, then we are not going to understand that point. We are not going to say that ki always the relation can be existing full. No. There will be a partial relation. Partial relation means out of all the elements, 2 can be existing. 2 can be existing. So that is also a relation. Every element of A cross B, because just understand this point. This here only mistake is coming. See, every element of A cross B, there can be 2 to the power n. How many elements are there? That many relations possible. That many relations possible. How many relations possible? Because subsets. How many subsets of this one you can form? That many relations possible. That many relations possible. Understand this point, Vikash, because this is the most basic point I am discussing right now. So you have to have a grip in all these points. So now look here. If I am telling that ki 4 elements are there, 4 elements are there, then how many relations possible? How many total number of relations possible? How many total number of relations possible? Think about it. 4 elements are there. How many total number of relations possible? One relation where there is no existence of relation means nothing, no relation. No relation means 5. So one of the relation will be 5. Gone, dead. This is 5 relation. Now another relation will be, one common element will be there. That is one thing common between them. Then another relation can be 1, 3 will be there. Another relation can be 2, 2 will be there. Then one set will be there when relation will be 1, 2 and 1, 3. Like this, how many relations can be possible? Yes, absolute. Now you have understood this point. So this is exactly how many elements are see how many subsets of a set is possible. That many relations can exist. That many relations can exist. That means 2 to the power number of elements of A cross B that many relation possible. That many relation possible, not one. You will be thinking that ki only one relation will be possible. I just showed you one relation in that. Now there will be total 16 relations possible. Fine. From this 4 elements we can make any, see, in case if they will be saying a relation like R is equal to X comma Y such that X and Y both are divisible by 5. Go for it. What answer you are going to give? Both are divisible by 5. What answer you are going to give? Okay, Gautam. I'm going to explain with another example. But give me the answer of this. Give me the answer of this, huh? Think about it, you will be able to answer the question. It's simple. There is no relation. There is nothing there common. Think about it. They are telling that x and y both are divisible by 7. Is there any element which is divisible by 7? Because think about it. Is there any element here? Is 1 divisible by 5? Is 2 divisible by 5? Is 1 divisible by 5 or is 2 divisible by 5? Jabin, good evening Jabin. Is 1 divisible by 5 or 2 divisible by 5? 1 divisible by 3, 2 divisible by 3. No, 2 divisible by 5. Yes Jabin, good evening Jabin. How are you Jabin? What are you doing Jabin? So here one thing we have seen that I hope you are doing your homework Jabin. Tomorrow is parents teacher meeting Jabin. I will be available Jabin. So just one simple example Gautam. I started talking with Jabin. Fine. Rohit is laughing. Fine Rohit. Tomorrow Jabin will not be present, Now look here. Just understand this one. I'm just going to explain another example because did you understood this point? Because here this will be empty relation. That condition will be empty relation. Just now I am going to form this. Good night ma'am. Good night Jabin. God bless you. We will be meeting tomorrow Jabin, huh? So question is, take this one. So now relation R1, R2, R3. Now one by one. Very good, soup. Super. You have understood the point. Super. Congratulations. God bless you all. Now look here, beta. First, what I have done, I took set A with 3 elements. I took set B with 2 elements. First, I formed a Cartesian product, and I told you now, whatever relation will come, it will come from the family only. Okay. Now first relation, what they are telling that ki x and y both are divisible by 2. So which and all are the element where x and y both are divisible by 2? So the first one, Vikas, Nitesh, Gautam, everyone, you are exactly absolutely correct, beta. 2, 4 and then 4, 4. So here it is exactly going to come as 2, 4 and 4, 4. Now second one, relation, tell me. Second relation Nitish is telling it is going to come as 5. Second relation Gautam is also telling as 5. Vikas is telling it is going to be, B answer is going to be C, 5 only. Okay, very good. So all of them has given as 5. Let's check this one out. X is greater than y. Here every time we are saying that 2 is less than 4 because 2 is the first number now. In the ordered pair, first you are writing x and then you are writing y. First you are writing which one? First you are writing x and then you are writing y. So here x is here, whatever elements are there, either they are equal to or they are less than. So 100% none of them are exactly less, none of them are exactly greater. So here definitely answer is coming as 5. Now here x plus y equal to 6. So 100% which one you are going to talk about? 2 and 4. And then 7, 8, 8, 9. So only 2, 4. Only 2, 4. Next one. Product of xy is a prime number. How can product of two number will be a prime number? Let's see this one. 8 is coming. 10 is coming. 12 is coming. 15 is coming. 16 is coming. 20 is coming. Any one of them is prime number? Any one of them is prime number? Yes. The answer will be coming as 5. The answer will be coming as 5. So I hope you might have understood a very important point, and that important point is कि when you are finding different relations, sometime the relation will be exactly containing the full set, means the relation will be very strong and it will be containing all the elements. Okay, sometimes the relation will be empty, nothing will be there, only 5 will be there. Sometimes the relation can be containing 1 element, sometimes the relation can be containing 2 elements. I hope you might have understood. So what in all, now Gautam, your question, because you had confusion now. So now look here Gautam, how many elements are there in A cross B? Gautam, count and say first. How many elements are present in A cross B? How many elements are present in A cross B, beta? How many elements are present in A cross B, Gautam? Come on, you can do it. Tell. How many elements are present in A cross B? Six is there na, because so now beta, that means number of relations possible. Cardinal number of A cross B is coming as 6. Means there are 6 elements in A cross B. Now, how many relations possible? Total number of relations possible is total number of relations possible is 2 to the power 6. Total number of relations possible is 2 to the power 6. Correct, Gopi? Total number of relation possible is 2 to the power 6. That it will become 2 into 2 into 2 into 2 into 2 into 2. 2, 4, 8, 16, 32, 64. So total it is exactly coming as 64 relations are possible. 64 relations are possible, and in that 64 relation, one relation will be universal relation. Means look here, one relation will be universal relation and one relation will be void relation. One relation will be universal relation and one relation will be void relation. What is universal relation and what is void relation? out of that 64, one relation will be universal relation. Universal relation means कि when relation itself will become equal to Cartesian product of A cross B, it is coming as universal relation. And when what is void relation? Void relation is R will become equal to 5, empty relation or void relation. I hope you might have understood this one. What is universal relation and what is void relation? Most of the time relation will not be universal or relation will not be void. Sometime itself the relation will be universal or sometime only the relation will be void. When the relation will be void means nothing common, and when the relation will be universal means everything common. Back to back, A cross B will be equal to R. A cross B equal to R. Oh my God, I started teaching relation, but I didn't taught you the definition of relation. What type of teacher I am? I didn't inform you the definition of relation and I started teaching about relation. But I think after this you will itself be able to find the relation definition. So that means we came to know that relation is a part of Cartesian product. So we are going to say that relation is exactly a subset of A cross B. Means कि whatever relations we are forming is related to every element of set B. Very good. Every element of set A is related to every element of set B, or in the most simplest way we are going to say that a relation is exactly a set of element of A cross B. A relation is a set of element of A cross B. That's it. This is the definition, and we have seen definition with the example here. What we have done, we didn't started with definition. Usually people starts with definition, and you know what, it is very difficult to understand. If I will be a student and definition somebody will tell me, I'll say that you keep that definition with you. You first explain me what is the point. So we have understood one very important thing here, that this is exactly talking about relation. So relation can either be a proper set of A cross B or relation can be equal to A cross B. That means relation is a subset of A cross B. That is, relation is a subset of A cross B. Why laughing? Because relation is a subset of A cross B. Whenever we are saying that relation A is related to B, whenever we are exactly saying that relation A is related to B, then one element will be there and that element will be a part of relation. That element will be a part of relation. First बताओ विकास, तुम हंस क्यों रहा है? Why you are laughing, विकास? Tell me fast, why you are laughing? Yeah, because we didn't started with example. Sorry, we didn't started with definition. We started with something else and we proved our point that this is exactly relation. And next time if somebody will be telling you, do the same thing, you prove that this is relation. Don't go and give the definition of relation. It will not be existing, okay? Yeah, what type of teacher? You tell me, what type of teacher I am here? Waste only. Don't know the definition of relation, Yeah, I started with relation. I didn't give the definition of relation. We itself generated the definition of relation. Come on. So now that means relation can be equal to A cross B and relation can be a subset or proper set of A cross B. So this is the most important point of relation. Okay. This is the most important point of relation. And another important point of relation is that whenever in relation any element will be there. In relation, whatever elements are present there, A comma B, A comma C, whatever elements are present in this relation, it will always be presented how we are writing A is related to B or AB belongs to R. Because we know one very important point that an element belongs to a set. An element belongs to a set. So if an element is belonging to a set, because an element is belonging to a set. So once an element is exactly belonging to a set, I hope you might have understood this point that A is related to B. We are exactly saying it as A is related to B or AB belongs to R. A is related to B and AB belongs to R. Understood, sir? Shall I go back to the next point? Next point. Shall I? So till here we have understood about relation. Now we are going to talk about the domain of a relation and the range of a relation. Here range is not that what can be the extent of relation. No. Domain of a relation and range of a relation. Now what can be domain of relation and what can be range of relation? So if element A is 1, 2, 3, element B is exactly 1 and 2 and A is related to B, means A cross B we are writing. Understood everyone? Super Nitish Gautam. Because so A cross B when you are writing, it will become 1, 1, 1, 2, 2, 1, 2, 2, 3, 1 and 3, 2. 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2. Now here, first we are going to generate one relation and after that we are going to talk about what is the domain of relation and what is the range of relation. Fine. So relation is x, y such that x is x, y such that x and y are odd numbers. So x, y such that x and y are odd numbers. Now what can all be the relations here? What can all be the relations here? Come on, start. What can all be the relations here? What can all be the relations? Find the relations here. Both are odd. Okay. 1, 1, 3, 1. Fine. Let's check this one out. 1, 1 odd number. Both are odd. 1, 1, 3, 1. Absolute. Now find domain of R. And find range of R. Now first thing is that we are going to just check the mapping. Okay. 2 is an even number. Nitesh, 2 is an even number. Marungi. 2 is an even number. 2 is an even number. Yes. So domain is exactly coming as 1, 3. Range is coming as range is coming as what will be the range? Range is coming as 1. Absolute, yeah. Super Vikash, super Gautam. So here first we are going to write as A coming as 1 and 2 and 3. B is exactly coming as 1 and 2. Now here many are Cartesian products, but relation is 1 to 1 and 3 to 1. So domain is, see, whenever we do, here one important point to be noted, my lord, that is, when I'm just saying, my lord, you have to understand this point, that when you are taking the first one, this will be exactly coming as always domain. And the second one will always be called as codomain. And the mapped one is always called as rangem. That is range. I'm joking. It is exactly called as range. Fine. So now, the first circle is domain. The second circle is called as codomain. The first circle will be exactly representing by x. The second one will be exactly representing by y. And then the mapped element will be called as the range. The one which is exactly getting mapped is called as range. And range cannot be repeated, Gautam. So here the domain is exactly going to be 1, 3 and range is only 1. Repetition of element is not there. Repetition of element is avoided. You cannot repeat an element. Fine. You cannot repeat an element. Fine. So it is only going to be understood, Gautam. So here only going to be 1. Till now, whatever I discussed here, was that very difficult to understand? Was that very, very difficult to understand? Domain we discussed, relation we discussed, Cartesian's product we have discussed. We exactly played today. We didn't study anything. Equivalent set we discussed, equal set we have discussed. So we did nothing. We were just playing with the content. So domain will be exactly coming as domain will be there. So one question is there. If R1 relation is having one element, R1 relation is come on, you can do it. Domain and range of R1. Domain and range of R1. Do it. You can do it. Domain, yes. The one which is exactly present, see, the one which is related to B will be exactly called as domain. The one which is related to B will be called as domain. The one which will be related to B will be called as domain. A and B are domain. Gautam, Vikas, Nitish. Range is B and C. Come on, let's check this one out. So what is domain here? Absolute. All of you are correct. How was the class today? Did you understood what I taught today? Or everything went out of your brain? Say fast. How was the class? Then next class, I think tomorrow, no. Tomorrow I'll be keeping class. I'll just send in community post the timing for the class. Fine, understood now? So tomorrow I'll post in community post Vikas what is the timing of the class. प्रशांत को थोड़ा आशीर्वाद दे देना, कहाँ है वो पता चले, ठीक है? So tomorrow I'll be taking the class in evening only, and I'll tell the timing, huh? I'll tell the timing of the class. I hope you might have understood. Nitish understood. Gautam understood. Okay? Fine. Signing off. Going to sleep. Good night, everyone. Hard class. Was that hard class? Because seriously, huh? You were playing with the questions like anything, Vikas. Huh? And saying hard class. Danger class. Fine. Ironical. Okay. Bye, everyone. Good night.